5C, conditional probabilities and formulas. Okay, so first thing we're talking about is independent versus dependent events. All right, events are independent if the occurrence of one does not affect the probability of the second one. So let's look at 3 examples. Selecting a king from a deck of cards, not replacing it, and then selecting a queen. Okay, this would be an example of events that are dependent, because taking that one king out of the deck of cards changes the probability of me picking a queen, because it reduces the number of cards by 1. So those are dependent events because I do not replace it. If I replaced the card, then they would be independent events because the probability would be the same for picking the queen regardless of whether or not I picked the king first. Alright, tossing a coin that lands on heads, rolling a die, and getting a 6. Those are examples of independent events. Okay, when I toss the coin, that has no effect on what happens when I roll the die. Driving over 85 miles per hour and getting into a car accident. Those would be dependent events. The faster you drive, the more chance of something bad happening. You're not being able to stop, or not being able to stay on 2 wheels when you make a turn, or anything like that. Okay, so two-way table, we've seen this before. The probability that a card is a heart and a face card. Alright, well, heart and face card is right here. 3 out of 52. Easy enough, right? Okay, this is an AND probability. Alright, and so we're going to talk about there is a formula that can be used for probabilities as well. And so for AND, which is what we found there, the probability of A and B, the probability of a heart and a face card, we use a multiplication rule. So the probability of A and B happening is equal to the probability of A happening times the probability of B happening. So if it was a heart and a face card, there are 13 hearts in the deck, so 13 over 52, and there are 12 face cards. Alright, 13 over 52 times 12 over 52, and it's going to give me 156 over 2704. And if I simplify that fraction using my calculator, I'm going to get 3 over 52, which is exactly what we got when we used the table over here. Alright, so now you might be thinking, well, why would I ever do all this work and do this multiplication if I can just look on the table? The answer is because you are not always going to have to do probability problems with a table. Sometimes you're just going to be given some information, and you're not going to be able to write the table. You're not going to be able to make a two-way table, and so you have to be able to use these formulas to calculate probabilities. So here's an example. The probability that a particular knee surgery is successful is 0.85. Alright, find the probability that 3 knee surgeries are successful. So this is the probability that 1 is successful, and the second one is successful, and the third one is successful. So this is an AND probability, so I'm going to be multiplying. So the probability that the first one is successful is 0.85. The probability that the second one is successful is also 0.85. And the probability that the third knee surgery is successful is 0.85. So if I multiply those, I am going to get 0.61, and we'll just round it there. So the probability that 3 knee surgeries, we just randomly pick 3 knee surgeries out of all of the knee surgeries that were done, there is a 0.61 or 61% chance that all 3 of them are successful. Alright, find the probability that none of the 3 surgeries are successful. There's a couple different ways we could go about this. So first we could say if the probability that it's successful is 0.85, then the probability that it is not successful is 0.15. That's that complement rule. So if it's successful, then 1 minus 0.85 tells me what's the probability that it's not successful. So I could do 0.15 times 0.15 times 0.15. Or I could also say if the probability that 3 of them are successful is 0.61, then the probability that none of them are successful is 1 minus 0.61, which is 0.39. Okay, so either one of the ways you want to do that, that's fine with me. Find the probability that at least one of the 3 surgeries is successful.